welcome to True Projects. In this video, we are going to explain about a project titled A Driving Decision Strategy based on machine learning for an autonomous vehicle. The project explores the advancement in autonomous vehicle technology by leveraging the different information and communication technology. The operation of self-driving car is divided into the three stages, that is of recognition, judgment and control. In the recognition stage, a variety of sensors like GPS, cameras and radars are utilized to perceive and gather the information about the surrounding environment. The judgment stage involves formulating a driving strategy based on the recognized information, analyzing the current condition of the vehicle and determining the appropriate driving plan, considering the driving environment and objective. The goal is to present a driving decision strategy that utilizes the machine learning to enhance the decision-making process of an autonomous vehicle. This strategy considers both the external factors such as pedestrians and the road conditions and internal factors of the vehicle such as consumer conditions and RPM levels. By leveraging the sensor data from the vehicle stored in the cloud, the DDS learns a genetic algorithm to determine the most efficient driving strategy for an autonomous vehicle. The objective is to minimize in-vehicle computation by leveraging the cloud to generate the extensive data on vehicle driving and utilizing the historical data to determine an optional driving strategy. These are the requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to build this project. The first module is upload the historical trajectory dataset. In this module, the focus is on uploading the historical vehicle trajectory dataset, which contains sensory data and corresponding class label. The dataset likely include the trajectory IDs, start and end times, average and maximum RPM values, average and maximum speed values, and of many more. In the second module, generate train and test model. This module is responsible for generating the train and test model that will be used for training and evaluating the machine learning algorithm. The dataset is split into training and testing as of 80% of dataset is used for training and 20% of dataset is used for testing the model performance. The third module is run random forest algorithm. This module executes the random forest algorithm, a popular machine learning algorithm for classification tasks, and applies the algorithm to the train model that is to be generated on the previous step. Using this, the historical vehicle trajectory data as the training data, the random forest constructs a multiple decision trees and combines the prediction to make the accurate classification. And the fourth module is run MLP algorithm. This module focuses on running the multi-layer perception algorithm. It is a type of artificial neural network that consisting of multiple layers of interconnected neurons and commonly used for classification tasks. And this model utilizes the train model generated earlier and applies the MLP algorithm to it. Using this, the historical vehicle trajectory dataset as of the training data will be applied and to be predicted the performance by using the tested data. And the fifth module is run DDS with genetic algorithm. In this module, it implements the DDS algorithm, which incorporates a genetic algorithm for enhanced decision making and prediction. It utilizes the train model and applies the DDS algorithm, which likely involves iteratively optimizing the genetic algorithm parameters to find the optimal gene values. And the sixth module is run DDS with genetic and XGBoost. This module extends the DDS algorithm by incorporating the XGBoost, a gradient boosting algorithm known for its performance in classification tasks. This module combines the genetic algorithm and XGBoost, leveraging their complementary strength to enhance the driving decision strategy. And the final module is accuracy comparison graph. This module generates a graph that facilitates a visual comparison of the accuracy achieved by different algorithms. It plots the accuracy scores obtained from the random forest, MLP, DDS and with the genetic algorithm and DDS with genetic and XGBoost algorithm. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is driving dataset folder consisting of the dataset and the test dataset. And the DDS and the test is the Python code file and the run is a bat file. Instead of executing the project and command line interface, we created a Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Historical Trajectory Dataset. By this, we are importing the dataset from the dataset folder and click on Open button. Here, we get a screen of dataset is loaded and click on Generate the Train and Test Model. By this, the pre-processed dataset will be splitted into the training and testing part. As of dataset length is of 977, the dataset is divided for the training, that is of 781, and the testing, that is of 196. And then click on Run Random Forest Algorithm button. By this, the random forest model is generated on the dataset with giving an accuracy of 67, F measure of 66, recall of 67 and precision of 67. And then click on Run MLP algorithm. By this, the multi-layer perceptron algorithm model is generated on the dataset with giving an accuracy of 48, F measure of 42, recall of 45 and precision of 48. And then click on Run DDS with Genetic Algorithm button. By this, the DDS with genetic model is generated on the data set with giving an accuracy of 77, F measure of 76 and recall of 76 and precision of 76. Then click on Extension DDS with Genetic and XGBoost. Here, the extension of the DDS with genetic and XGBoost model is generated on the pre-processed data set with giving an accuracy of 98%, F measure of 74%, recall of 75% and precision of 73%. And then click on Accuracy Comparison Graph button. By this, we get a bar graph where x-axis represents the algorithms we used and the y-axis represents the value assigned for each algorithm's accuracy. And then close this graph. And then click on Predict the DDS type button. Here, it redirected to the driving dataset folder consisting of dataset and test data. Here, we need to select the test data and click on Open button. Here, we get a screen of the like this where the data present between the square bracket is of the test record and the decision strategy for this test record is of lane change, and for this test record it detected as of steering angle. For this test record the strategy is speed. In this way we can recognize the driving decision strategy by using these various machine learning models. In conclusion, the project proposed a driving decision strategy based on machine learning for an autonomous vehicle that takes into account both external and internal factors of the vehicle. The DDS learns a genetic algorithm using sensor data from vehicles stored in the cloud and determines the optimal driving strategy of an autonomous vehicle. It includes that the proposed DDS can improve the driving performance of autonomous vehicle by considering the both external and internal factors of the vehicle and by utilizing the machine learning techniques.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.